And good day, Algebra. We're going to do CO43, which is adding and subtracting polynomials. In last class, it was brought up that the objective says polynomials, despite having trinomials down here, some binomials there. I didn't tell you yesterday, because I really wanted you to work with the actual names, but technically, all types of nomials, whether it's monomial, binomial, or a trinomial, are all considered polynomials. Kind of like all shapes are considered polygons, but some have certain names: triangles, quadrilateral, pentagon, etc. Same kind of thing here. So a trinomial is a polynomial. But I didn't tell you that because I didn't want you to just write everything as a polynomial, take kind of the easy way out. But so there. Sorry for that. Okay. So we're adding and subtracting polynomials today. And since we've done PO40, you'll find that there's really only... nothing about this math is new, but the details are really going to matter here, okay? So if you are someone who typically doesn't have any rhyme or reason to showing your work, or maybe doesn't show your work, you'll probably find you get caught up with things like negative signs and operations in doing CO43. So a very organized method is what we're going for here. But step one, we want to make sure and write each expression in standard form. Standard form is important here because we're going to be combining like terms, and standard form very, specifically spells out, your powers are greatest to least. Everything is right there for you. So each expression in standard form. Step two, you are going to align the expressions vertically, just like you did when you were first taught how to add and subtract back in first grade and second grade, right? Align the expressions vertically, leaving spaces for missing terms. And that phrase missing terms, I'll get back to that, exactly what that means in a little bit. So align the expressions vertically, leaving spaces for the missing terms, if there are any. And then step three is add or subtract, depending on what the operation is telling you to do. Okay. Give me a thumbs up when you're done with the notes, and then we'll move on down to, was that a hand up earlier? No? Okay. Sometimes I see things that aren't actually there, All right. Okay, go ahead. Are you through the notes? Yeah. Oh, then that's a thumbs up. So more to do. Okay. So let's look at the first one here. It says 3x squared plus 5x plus 9 plus 8x squared plus 12x plus 1. So you can see that our two expressions are kind of isolated inside the parentheses there. And they're already in standard form for us, which is helpful. And so now we can look for, are there any missing terms? And what I mean by that is we see we have an x squared term in our first expression. Is there also an x squared term in the second one? Yes. There's an x term in the first one. Is there also an x term in the second one? Yes. There's a constant in the first one. Is there also a constant in the second one? Yes. So because every term has a like term in the other expression, we don't have to worry about any missing terms here. So we're just going to align them vertically. 3x squared plus 5x plus 9. And then below that, our second expression, 8x squared plus 12x plus 1. And again, we're lining up those like terms. Our operation is addition. And it's really now kind of back to PO40. When we just combine expressions using the elimination method. We're not trying to get ox or oi here, but it's that same combining feature. So 3x squared plus 8x squared gives us 11x squared. 5x plus 12x is 17x. And 9 plus 1 is positive 10. That's it. Seriously. Okay? Like I said, there's no equal sign, right? So we're not solving for the value of x, but we have combined these two expressions with addition. Right? Okay. Let's take a look at the second one. Both are in standard form. Both have an x term, and both have a constant. So again, nothing really to worry about here. Just align them vertically. 17x minus 4, 9x plus 10. Our operation is addition. And now we add. 17x plus 9x is 16x. Negative 4 plus 10. Thank you. Negative 4 plus 10 is positive 6. Here I thought you were correcting me because I missed the x, and here I don't know how to add 17 and 9. 26x plus 6. I added 7 and 9, not 17 and 9. Sometimes I see things that aren't there. Sometimes I don't see things that are there. It's a real struggle. Okay? 26x plus 6. Question so far? Are you like waiting for the big, but wait. Number 4? Okay. So, well, let's do number 3 first to gain a little bit more confidence before we get to number 4 here. So we have 9x cubed plus 4 minus 15x plus 3. There's an x cubed term in each of them, a constant in each of them, so no missing terms. We're going to line them vertically. 9x squared plus 4. 15x cubed. I said x squared, didn't I? I'm derailing quickly. And we are subtracting this time. Okay. With subtraction, as it always has, the order matters. So the expression that is listed first is what should go on top. With addition, it doesn't make a difference because you can add things in either order and it ends up being the same. Not so much with subtraction. So when you're subtracting, make sure that first expression goes on top and the second one on the bottom. And so now we've got 9x cubed minus 15x cubed. That's negative 6x cubed. And then 4 minus 3 is a positive 1. Good? Number 4. 13x minus 10 minus 5x squared plus 2. So here's what I mean by missing terms, right? I've got an x term in my first expression, but not my second one. I've got an x squared term in the second one, but not my first one. Daniel? Yes. Well, if you put the 15x cubed up on top, yeah. If you did that, then your signs down here would just be opposite. It'd be a positive 6 cubed and a minus 1. It'd be like if I asked you to take 10 minus 6, and you said, well, can't I just take 6 minus 10? Well, no, because they're different values. So with subtraction, the order does matter. What's listed first should go on top. Okay. All right. So when I write out that first expression, 13x minus 10, nothing really changes because they're right next to each other in standard form anyway. But when I write that 5x squared plus 2, why don't I want to put my 5x squared beneath my 13x? Why is that a bad math move? Elise? Can I just combine those? 13 minus 5? No, why not? Because they're not like terms, right? One of them is at x squared. So I need to put that 5x squared out in front where an x squared term would go if I'd had one in the first expression. Okay? And then I don't want to put my positive 2 beneath my 13x because I can't combine those. I want to leave a space where an x term would go if I'd had one and put the positive 2 below my negative 10. So I'm still aligning like terms. Okay? And what I highly advise you do here if we don't have any x squareds in the first expression, I'm actually going to write that by representing it as a 0x squared. And you'll see why there's a method to the madness here coming up. And I don't have any x's in my second expression. I want to actually write that by putting in a plus 0x here. Just remind myself. Because when I go to subtract here, it's a logical common mistake to think, oh, there aren't any 5x squared, or there aren't any x squareds in that first expression. This 5x squared just drops down. But it doesn't just drop down. Because I have no x squareds in my first expression, and I'm subtracting 5x squared from that. And 0 minus 5 is a negative 5. So at least when you're first doing this, I highly recommend putting that 0x squared up on top to remind yourself that it is actually an operation here. It's 0 minus 5, not just bring the 5x squared down. My next one, 13x minus 0x, is still 13x. That can just drop down because I'm subtracting nothing from it, so it doesn't change. And then negative 10 minus 2 gives me what? Good, negative 12. Don't forget about those addition and subtraction rules from way back in PO3. I've got a negative 10, I'm subtracting 2, and that gives me negative 12. So as you can see, I mean, there's nothing really new mathematically here, other than just paying attention to the details of aligning up our like terms and remembering those operation rules for subtracting negatives and adding negatives and doing all that stuff. Emily.
Could you also write it as 13x minus 5x squared minus 12?
You want your answer in standard form, so no. In standard form should be greatest to least power. Did I lose anybody with that fourth one, or are we still all good? Great. All right. Which one from the top row would you like to do together on the second page? It will all be homework. We'll open it up to the bottom section in just a bit, but this top row, which one looks particularly like worth doing in class? No takers? All right, I will do the first one. So 21x to the fourth plus 15x squared minus 2x minus 4x to the fourth minus 3x squared plus 4x plus 3. I do see, excuse me, I'm going to have to leave some spaces here. Not really too bad because I've got an x to the fourth. There's no x cubed in either of them. And then I have an x squared, an x, and really the only space is that last constant. So I'm subtracting. I have to make sure that my first expression is listed first and that I write it correctly. What's going on with me today? Plus 15x squared minus 2x. And then that second expression, 4x to the fourth goes beneath my x to the fourth term, then minus 3x squared plus 4x, and then plus 3. And again, I recommend putting that plus 0 up top to remind yourself that that's just a placeholder. I've got nothing there. It is a 0. Especially since we're subtracting. So 21x to the fourth minus 4x to the fourth is 17x to the fourth. 15x squared minus negative 3x squared. This is something to watch out for. We're subtracting a negative number, which our operation rules tell us is actually what? Subtracting a negative is actually what? Addition, right? So 15 plus 3 gives me plus 18x squared. And then negative 2 minus 4x is a negative 6x. And 0 minus 3 is a negative 3. So what I want you to look for, if you worked ahead and already did this one and you look up and say, ooh, that's not what I got. If your numbers are wrong, Okay, make sure you did the correct operation, that you accounted for that negative sign that you're subtracting and the signs of the numbers in that second expression. If your sign is wrong here, then it's probably because you just brought down the 3 rather than remembering, oh yeah, it's 0 minus 3. 0 minus 3. Okay. Another one for us to do together. Any of them? Oh, shocker. Okay. That's okay though. Oof. Oof. All right. So this is not only not written in standard form for us, but we also have a whole bunch of missing terms here. We are subtracting, so that first expression needs to be on top. And I notice I've got a 15x to the 5th. That's my highest power, so that goes first. I don't have an x to the 4th, but I do in my second one. So I need to leave a space for that. I don't have an x cubed, but I do in my second one. So I need to leave a space for that. The next term I'm going to write in my first expression is my negative 18x squared. That's going to be all the way over here, to leave space for an x to the 4th term and an x cubed term that I don't have, but I do in the second one. Then I've got a negative 20x, and I've got a positive 3. Yes. Okay. In my second expression, I don't have an x to the 5th, so I'm going to put my 9x to the 4th in its place, where it would go if I'd had one in the first expression. My negative 8x cubed comes next, where an x cubed term would go. Then I've got a positive 3x squared, a negative 20x, whoops, and a positive 3. Again, I recommend filling in these empty spots with an x to the 4th and an x cubed, and down here with a 0x to the 5th. Okay, just to fill in those place value holders. I'm subtracting these equations. 15x to the 5th minus 0x to the 5th is still a 15x to the 5th. 0x to the 4th minus 9x to the 4th is a negative 9x to the 4th. Again, the value of having that 0 there. 0x cubed minus negative 8x cubed. How many x cubes do we have? 8 of them. Positive. 0 minus negative 8 is a positive 8. How many x squareds do we have in our answer?
0.
How many x squareds do we have in our answer? Negative 21. Negative 18 minus positive 3 is a negative 21 x squared. How many x's? How many x's? 0. They cancel out. Negative 20 minus negative 20. Negative 20 plus 20 equals 0. Does that mean that I put an x here? Because they all canceled out? No, because how many x's is that? 1. I don't have 1. I've got 0. So if they all cancel out, put nothing. If you want to put a 0x, just for funsies, fine. Okay? But don't just put an x. That actually means you have 1. And then my constant, 3 minus 3, 0 also. Okay? 0 also. Make sure you're going back to that subtraction sign every single time. So final answer, 15x to the 5th minus 9x to the 4th plus 8x cubed minus 21x squared. Okay? You can probably see now why I preface this by saying the details matter. Pay attention to signs. Pay attention to powers. Notice that these exponents didn't change when I did my subtraction. We kind of related this back to fractions. You know, for fractions, you need those common denominators that stay the same when you add or subtract. Same thing here. You need the like terms. And that part, that variable part and the power part doesn't change. Only the coefficients do. Okay? Feeling good? All right. The homework is the rest of the page. And so finish up 42 for tomorrow. And that's how math.